Hey guys, today we're going to be solving number 55 out of the physics textbook. So the question reads, a hawk is flying horizontally at 10 meters per second in a straight line, 200 meters above the ground. A mouse it has been carrying struggles free from its talons. The hawk continues on its path at the same speed for 2 seconds before attempting to retrieve its prey. To accomplish retrieval, it dives in a straight line at a constant speed and recaptures the mouse 3 meters above the ground. Assuming that no air resistance acts on the mouse, find the diving speed of the hawk. B. What angle did the hawk make with the horizontal during its descent? And C. For how long did the mouse enjoy the free fall? Okay, so I have a simple diagram drawn out here. The bottom line is the ground. The second line is 3 meters above the ground, and this is the path of the flight of the hawk, which is 200 meters above the ground. So n0 is directly below the hawk at the starting point. So this curve, or this dotted line, will represent the path that the mouse takes during its free fall, and the red line is the descent of the hawk. Okay, so the first thing it asks for us to find is the speed of the hawk during its descent. And in order to find this, the first thing I decided to find was the time time between the hawk losing the mouse and the hawk regaining the mouse. And I did this using this kinematic, and so delta x, we know that the mouse is going to travel negative 197 meters. And since velocity is 0 when it is dropped, we just have to look at the acceleration part of this kinematic, and that is 1/2 times negative 9.8 meters per second squared times t squared. And if we work this all out, we get that the mouse was falling for 6.34 seconds. So the time between the hawk dropping the mouse and regaining the mouse is 6.34 seconds. Now using this, we can figure out how far the mouse and the hawk travel horizontally, and you do this using the kinematic. And since the acceleration, there is no acceleration, since it's constant speed of 10 meters per second, we just multiply that by time, and we get that horizontally both traveled 63.41 meters. So using this, we can, to put it in coordinate form, the mouse and the hawk collide at 63.41 meters horizontally and 3 meters above the ground. So during the first 2 seconds, the hawk just continues on its path with a constant velocity, and so the horizontal distance that it covers is 20 meters, because the velocity times the time will give you 20 meters. So it's going to actually descend from the point 20 meters horizontal and 200 meters above the ground. So now we can use this to find the velocity of the hawk's descent using this kinematic. The equation that the hawk covers on its descent can be found using Pythagorean theorem, because we know the point that it's going to retrieve the mouse at, and we also know the point that it is descending from. We use the Pythagorean theorem to calculate the distance that it covers on this descent, and then we divide this by the time to give us the velocity of the descent, which is 46.48 meters per second, and this is your solution to part A. Now part B is asking you what is the angle, theta, that the hawk forms with the horizontal on its descent. And this is pretty easy to find. We need to use the inverse tangent. We need to use inverse tangent to find this. So as it works here, theta equals inverse tangent 197 meters over 43.41 meters. Now where did I get these numbers? The 197 meters obviously is the opposite, and it falls 197 meters total. The horizontal distance that the hawk covers during its descent is the total 63.41 meters that it covered horizontally over the entire course of this whole retrieval, but minus the 20 meters that it covers horizontally at the beginning to where it starts its descent. So it's 63.41 minus 20, which gives you 43.41. And so when we solve it all out, theta is 77.57 degrees below the horizontal x-axis. And then C, time equals 6.34 seconds. If you remember, we already solved that out at the very beginning when we were trying to solve for the velocity of the hawk during its descent. And we just did that using this kinematic. Negative 197 equals the acceleration part because the velocity was 0 when the mouse was dropped, and we get that time is 6.34 seconds. Alrighty, so hopefully this helps you guys out if you're having trouble with this problem. Thanks.